Okay, we are here with our student Rita, and we're going to be talking about substituting and testing values in equations. This is one way to find the solution to an equation. We'll start off with some starter examples, and then we'll do some harder ones, okay?
Okay.
All right, so let's first look at an equation here. X plus 5 equals 17. Now, you probably can figure that out just in your head. There's some number plus 5 equals 17. What is that number probably?
12.
Yeah, so 12 would be the right number to go in here. That's kind of obvious, but let's show you, use this really simple example to show you how you can use a table to substitute and test for values to see if the values are true, if they make the equation true. So the way you set up a table like this is to go ahead and have some column for x. These are the values that you're going to try in the equation for x. And then you go ahead and in your second column, you'll actually write out that equation substituting the number for x. So here was 0, and I put in 0 for x, so I have 0 plus 5 equals 17. And then in the far right column, you'll ask yourself, does that make the equation true? So 0 plus 5 is 5. That does not equal 17, so I'll write false there. Does that make sense?
Yeah.
Okay. Now this one, I tried the value 10. 10 plus 5 equals 17. Does 10 plus 5 equal 17?
No.
That's also false, right?
Mm-hmm.
Okay, good. So let's just keep going and try these next two values. So tell me what I should write right here.
11 plus 5 equals 17.
Okay, good. And is that true?
No.
So we're going to go ahead and write false there, right?
Right.
Okay, what should I write on the next row down?
12 plus 5 equals 17.
Like that?
Yep.
Okay, and is 12 plus 5 equals 17?
Yes.
Okay, so that's true, and we can go ahead and circle 12 there because that's our answer, just like you said at the beginning. Now this is a pretty simple example that you can do in your head. Let's try a little bit of a harder example. This is 72 over a, or 72 divided by a, equals 8. I'm going to go ahead and set up a table just like we did up above. And we have done the first row there. So for a equals 3, we substitute the 3 right here in for a. 72 divided by 3, just like 72 divided by a. We're trying out 3 for a to see if it makes it true. Now 72 divided by 3, you might use a calculator for that, or you might be able to do mental math. That's 24. Does 24 equal 8?
No.
Okay, so we're going to put false there. Okay, so tell me what I should write in this next row.
72 divided by 6 equals 8.
Okay, so let's go ahead and write that. Now 72 divided by 6, you might know that from your times tables. What's that?
12.
So does 12 equal 8?
No.
So that's false also. How about the next row? What should we write?
72 divided by 9 equals 8.
Okay, and what is 72 divided by 9?
8.
8. So that's actually true, right?
Right.
And we've found our solution, so we can go ahead and circle the 9 there as the answer. That's the one number that will make the equation 72 divided by a equals 8. 9 is the only solution that will work, right?
Right.
Okay, great. So now let's get over to some harder examples that are much harder to do in your head, and you'll start to see why it's important to write these things out rather than just guessing at the answer all in your head. So the equation here we have is 3c plus 2 equals 14. Probably a lot harder just to do that in your head. Eventually you'll learn how to solve this by doing algebra, but we can always test values in a table. So what I've done here is I've set up a very similar table where I have c here with some different values we're going to try. And then we're going to go ahead and substitute the value in. So here I've written, instead of 3 times c plus 2, I have 3 times 2 plus 2. And I wrote that that equals 6 plus 2, because 3 times 2 is 6. And 6 plus 2 equals 14. I wrote equals 14 because that's what the equation says. But we know that 6 plus 2 doesn't equal 14, so that's false, right?
Right.
Okay, so why don't you tell me what to write right here if we try the value of 3 for c?
3 times 3 plus 2 equals 14.
Okay, and what is 3 times 3?
9.
9 plus 2, does 9 plus 2 equal 14?
No.
Okay, so we're going to go ahead and write what in the far right-hand column?
False.
False, good. Okay, now how about this next one with a value of 4? What should we write there?
3 times 4 plus 2 equals 14.
Okay, good. So 3 times 4 plus 2, and what is 3 times 4?
12.
Good. So right here we're making the calculation 12 plus 2 equals 14. And does 12 plus 2 equal 14?
Yes.
Okay, good. So again, we can put true right there, and we've found the correct value for, so we'll go ahead and circle that. And we know that we found the one solution that makes the equation true. Okay, and let's try an even harder example here. So now, oh wow, so this one, 3y minus 7 equals 2y plus 3. Without doing algebra, I can't tell you what the answer is there. So it's not obvious to me like this one over here was. So making a table is really going to help us here. And I'm going to go ahead and set up a table with a couple of values trying here for y. And let me show you how to do it when you have variables on both sides. You really want to write everything out. So the value we're going to try for y is 5. So not just in this first spot, but also in this second spot over here, we have to put 5 in for y. So that's what's written here. 3 times 5 minus 7 is the same as 3y minus 7 equals 2 times 5 plus 3, which is the same as 2y plus 3 when y equals 5. Does that make sense?
Yeah.
Okay, now we can start just simplifying here. So 3 times 5 is 15 minus 7 on the left side, and 2 times 5 is 10 plus 3 on the right side. And then 15 minus 7 is 8, 10 plus 3 is 13, 8 equals 13. That is totally untrue. 8 does not equal 13, so we write false. Okay?
Okay.
All right, so we can try many other values. Didn't have a lot of space here, so I'm going to try one other value here. You can probably guess that this will end up being the correct answer, but to get to that correct answer, tell me what I should write right here.
3 times 10 minus 7 equals 2 times 10 plus 3.
Like that?
Yeah.
Okay, great. Now, we're going to simplify the left side and the right side. So what should we write on the next row?
30 minus 7 equals 20 plus 3.
Very good. Like that?
Yes.
Okay. Now, what's 30 minus 7?
23.
And what's 20 plus 3?
23.
So we have 23 equals 23. Magically, the two sides are equal to one another. So is that true?
Yes.
It is true, right? So we can circle that 10 as our correct answer. So what have we learned how to do? Well, before you know how to use algebra, you can always set up tables to try to find the correct answer by testing different values that you substitute into the equation, and eventually you'll get to the correct answer. Make sense?
Yep.
Very good.